This lesson explores factoring trinomials. And remember that a trinomial is a polynomial that has 3 terms in it. And when I actually factor trinomials, what I use is what we call the rooftop method. There's different types of factoring for different methods. In the previous lesson that we looked at, we had 4 terms, and so therefore we tried grouping. So in this case, when we use the rooftop method, we make sure it's in descending order. We take the coefficient of the lead term, which in this case right here would be an understood 1. And that's my lead term because it has a degree of 2. Remember, this has a degree of 1, this has a degree of 0, so it's in descending order. So we take the first number and the last number and we multiply. And this method works every time with factoring trinomials. And so we'd say 1 times 20 is going to be 20. And then we're going to write down the factors of 20, which means everything that multiplies to give us 20. So 1 times 20, 2 times 10, and 4 times 5. At that point, my next factors would be 5 times 4, and since I already have 4 times 5 written down, I'm not going to go back and write everything else down again. So what I need to do is I need to look at my second sign. If my second sign is positive, then I want to add to get the middle coefficient. If my second sign is negative, I want to subtract to get my middle coefficient. So in this case, I need to add to get 9. So I have a pair over here, 4 and 5 will actually add to give me the sum of 9. And then I look and I say, okay, if my second sign is positive, my signs are going to be the same. If it's negative, I have opposite signs. Well, if they're the same, they're either both positive or they're both negatives. Well, look at the first sign. If you want a positive 9 and my signs have to be the same, then both of these are going to have to be positive. So I take positive 4 and positive 5 out, and I put a line underneath each of them. And then I take the coefficient of the highest degree term and the variable, which is just x, and I put that under each of those numbers. Then I put my parentheses. If it's something other than a 1, I need to check to see if these fractions reduce. Well, since it's 1 in the denominator, nothing's going to reduce. So here's my first factor. I'm just going to rewrite it as x plus 4. And my second factor is going to be x plus 5. Now, it doesn't matter if you write x plus 4 first or x plus 5 first. You have to have both of those written down, and if you wanted to check this, then you could use the full method to see that you have the original problem. Now, this problem is simple enough to be able to do this in our head, but the numbers are going to get larger, just like, for example, the second example with 54. That's going to be a little bit more to think about, especially when we get coefficients other than 1 in front. So I do encourage you to use this method. It works every time I'm factoring trinomials. So in this case, again, we have trinomials, so we have descending order. Things that you need to check. There's nothing we can take out of it to begin with. If there were, we would. We would say 1 times 54. Don't worry about the sign yet. 1 times 54 is going to give us 54. And then I'm going to go ahead and write down the factors of 54, which would be 1 times 54, 2 times 27, 3 times 18, and 6 times 9. And at that point, it would flip around to 9 times 6, so I'm going to stop right there. Look at your second sign. This is our first sign, this is our second sign. Look at the second sign. It says subtract to get the middle number, which is 3. Well, there's only one pair that subtracts to give me 3. It is 6 and 9. If my second sign is negative, then that means my signs are opposite over here. One's positive and one's negative. And if I want a positive 3, then that means the 9 has to be positive and the 6 has to be negative. That's the only way to be able to put those together to get that positive 3. So we take our negative 6 and our positive 9 out. That's what we've circled. And we put it over 1x. And again, if 1's in the denominator, nothing's going to reduce. So we're left with x minus 6 times x plus 9. And again, it does not matter which factor you write first, but the negative does have to go with the 6 and the positive does have to go with the 9. In our next example, we can take I factor out a y squared to begin with. They all have y squared in common. So when I factor out a y squared, I'm left with x squared plus 4x plus positive 3. And then I still need to check, I still have a trinomial, I need to check if this will factor anymore. So I have a 1. 1 times 3 is 3. And that's the only factor I have for 3. You have to ask yourself, look at the second sign. Can you add this to be able to get 4? Yes. Okay, so that's what we're going to use. 1 plus 3 does give us 4, but we want a positive 4. The second sign says the signs are the same. Either they're both positives or both negatives. The first sign says, hey, it's got to be a positive 1 and a positive 3. And you put positive 1 and positive 3 with a line underneath, and you put it underneath 1x because that's the part that you're factoring. which nothing's going to reduce, so you're left with x plus 1 times x plus 3. But don't forget the y squared that we factored out originally, because if we fold this out and distribute the y squared, we would get our original problem. So that would be your final answer. In the next example, we cannot factor anything out of these three terms. So we would go ahead and say 3 times 20 is going to give us 60. Alright, the factors of 60 are going to be 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. So it has a lot more factors, but it helps to write everything out so that you don't miss a pair that you could use. Look at the second sign. It says add to get the middle number. Add to get 19. Well, the only pair that adds to give me 19 is the 4 and the 15. I want a negative 19, so that this tells me, the second sign tells me, hey, your signs are the same. This negative sign says, hey, they're both going to be negatives. That's the only way to put those together and have a negative 19. So you take negative 4 and negative 15, and you put that over positive 3x. That's your first coefficient, the highest coefficient, or highest terms coefficient, which is 3. That's where it's coming from. And we look at this. The 3 and the 4 did not reduce, but the 3 and the 15 do. 3 divides into 15 5 times. So you're left with a factor of 3x minus 4 times x minus 5. And you do have to reduce that factor. Otherwise, you'd have a 3x there, and if you fold it, you'd have 9x squared. So in this case right here, that is your final answer. In this last example here, we can factor out a z. Therefore, we're left with 2x squared plus 5x minus 12. We still have to check to see if this trinomial factors any further. So when we look at this, we would say 2 times 12, and again, not worrying about the sign, 2 times 12 is 24. The factors of 24 are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. The second sign is negative, and it's saying subtract to get 5. Well, the only pair that I can subtract to get 5 is the 3 and the 8. And then I look at my second sign, it says your signs are going to be opposites. One's positive, one's negative, just because that's a minus sign. We want a positive 5, so that means that the 8 will have to be positive, and the 3 will have to be negative. So we take the negative 3 and the positive 8, what we've circled, put a line underneath, and put it underneath 2x, the coefficient and the variable. Make sure you have your variables correct. And then we see, does it reduce, because there's not a 1 in the denominator. The first fraction does not. The second one does. 2 divides into 8 4 times, so you're left with 2x minus 3 times x plus 4, and don't forget the z. And that would be the final answer. It does not matter what order that is written in.